Good afternoon, Caleb. Good afternoon, Henry. How are you guys doing today? Awesome. All right. Let's get going. Last week we talked about taking the derivatives of inverse function, like arcsine or inverse sine of 2x or tangent or whatever. It's basically a plug and chug rule when you think about it. These are fairly easy to do. All they entail is knowing what the function is that you need to plug it in. For example, if I wanted to find the arcsine of 2x, if I know that the derivative of arcsine is, oops, I better turn on my pencil here, u prime over the square root of 1 minus u squared, it's very simple. This is my u value right here. So the derivative on top is going to be 2 over the square root of 1 minus, well, when you square 2x, you get 4x squared, don't you? So that would be my answer. Positive 2 over 1 minus 4x squared, or letter D. And all of them are basically the same. Sine, cosine, tangent, secant. It's just a formula that you have to be able to remember and just plug it in. Now, when we go over these in AB calculus, I tell the students that these are not the most important things to memorize. You're not going to, if you get one problem like this on an AP test, you'd be lucky. But in a BC calc, you might get 2 of these types of problems, so it might not be a bad idea to remember the rules. Okay, in this one, I have the arc tangent of cosine of x. Well, in this problem, this is my u. The arc tangent is u prime over 1 plus u squared. Okay, so if I was going to take the derivative of this, that's going to end up being, well, the derivative of cosine is negative sine of x all over 1 plus cosine squared of x. So it's just basically, as I said, it's just basically a plug and chug formula to get the answers. Okay, so my answer should be negative sine 1 plus cosine of x. Looks like letter A for that one. All right. Whoops, let's go back. Any questions from last week's material? Anything that you guys did not understand? Anything that you want to go over? Okay, Caleb's good. How was your last soccer game, Caleb? Four zero. Excellent. Now, do you guys go on to like state or anything like that?
No, but this weekend we have a national homeschool tournament in Indiana.
Awesome. So it's basically a traveling kind of team thing, or it's just that Indiana is the only place that they have it?
It's hosted open to teams across the nation, homeschool teams across the nation for a competitive tournament like atmosphere for the end of the season. So it's
Awesome.
not invitational or anything, but
Okay. So anybody could go there that wanted to? Any homeschool team?
I'm not entirely sure, but I think yeah, if any homeschool team, and then you put into one of 3 divisions, and then there's 12 teams in each division. So it's pretty huge.
Awesome. Well, good luck this weekend. Hopefully the weather is nice. Boy,
Yeah, thanks.
if it would have been this last past weekend, oh my goodness, so we have a beautiful weekend. That would have been amazing. All right. This week we are going to be, I think we're dealing with related rates, and then position, velocity, and acceleration. So pretty easy stuff this week. Related rates deal with how fast something changes. For example, let me, I don't want to do a problem yet, but let's say we have a metal disc, okay? And so we have this metal disc and we start heating this thing up, okay? So we put a fire underneath this thing. What's going to happen to that metal disc if we heat it up? Does it shrink? Does it get bigger?
It expands.
It expands, exactly. And this is where, when you think about engineers, this is where everything comes together. Because when well, let's say you're an engineer and you don't understand that heat expands, and you're making, I don't know how much you guys know about cars and pistons and stuff like that, but the piston goes up and down in your car, and that is metal, and that gets hot. I mean, super hot. And if they don't take in consideration the expansion of that metal, that motor is going to seize up. And that's why, if you know anything about motors, pistons have piston rings on them, and those do expand. They get bigger and smaller, and so do the pistons. But this is one of the places where calculus is used. It's used to find the expansion or how fast something is changing. And these problems are all dealt with when you take the derivative of each one of these. It is with respect to time. And time is a huge factor in these types of problems. And the biggest thing with these types of problems is being able to take the derivative with respect to time. So let's just take a look at some of these problems, and let's try to find the derivative. Okay, I want to leave letter A alone for the first one because it's probably the hardest one. But if I wanted to take the derivative of this, okay, you take the derivative just like you normally would, and then you just put dl, or for the example here, the derivative of p is, well, it's going to be, because let's pretend this is a 1, you bring that down, so this is going to be 1, the p would go away, but you have to say dp dt. So the derivative of p is just dp dt is equal to, well, the derivative of 2l is 2 times dl dt, plus the derivative of 2w is just 2 dw dt. The dt just with respect to time. Now, if I have something like 2 or a squared, this is going to be, I take the derivative like normal, so this would be 2a, but then since I'm taking the derivative with respect to time, it's going to be dA dt, plus, and then here, this is going to be 2b dB dt is equal to 2c dC dt, okay? Now, can you see why I left this one alone? Why is this one much harder than all of the others? So what makes that one so much harder than all of the others? Product rule. That's exactly right. We're gonna have to use the product rule on this thing. So if I take the derivative here, the derivative of A that's not a big deal. That's dA dt. However, when I take the derivative of L times W, I'm gonna have to go over here and say, okay, U is equal to L, U prime is equal to dL dt, W, or I'm sorry, U, or V, V is equal to W, and V prime is equal to dW dt. So my derivative is going to be the inside, so that's going to be W dL dt, plus outside, so that's going to be L dW dt. And the cool thing about these problems, I love these problems, is when you're solving one of these, you're going to be given all of the information except for one variable or derivative part. And sometimes you have to work to get those pieces of information. Sometimes those pieces of information aren't readily available. You have to read the problem, you have to figure things out. But these are, I think, some of the coolest problems there are. So let's take a look at a problem here. Okay, I love the ladder problems. And Caleb, since I had you last year, you've probably seen a lot of ladder problems. It says a 26-foot ladder leans against a building. Okay, so me, I'm a very visual learner, so I always draw out these really elaborate sketches here. Not really, but this is my ladder. It's 20 feet. does the ladder change in dimensions? When it's leaning against the wall, it's 26 feet. This is a constant, and anytime you have a related rate question that has a constant in it, you should be saying yes, because constants, anytime you take a derivative of a constant, something that's not changing, it's going to be 0. So whenever I see a constant in a problem, that is a good thing, because that means it's going to make the problem a whole lot easier to solve. Okay, so got a 26-foot ladder. That ladder is constant. Leans against the building so that its foot moves away from the building at a rate of 3 feet per second. Okay, so this is, let's call this A, and let's call this height B. So what did they just give me in the problem? Okay, they said that the rate, the ladder is moving away from the wall at a rate of 3 feet per second. So what did they just give me in this problem? Okay, so those are kind of things that you have to pull out of problems like this. You have to sit down and think, okay, what is that 3 feet per second? What is that? Okay. Using a diagram, what is 3 feet per second? Okay. Is it A? Is it B? Is it dAdt? Is it dBdt? Because those are all the things I'm going to need in order to solve this problem. Anytime you have a variable, you know you're going to end up with finding the derivative there. So in this problem, the 3 feet per second, that's dAdt. That's the rate at which A is moving. That's 3 feet per second. Okay, does that make sense? They just gave me dAdt. Okay. So now we'll continue. It says, when the foot of the ladder is 10 feet from the building. Okay, so now they're telling me that this is 10 feet from the building. Okay. The top is moving down at the rate of r feet per second. So this is moving down. So what am I looking for? Okay, what am I looking for? Okay, in terms of calculus, or in terms of this problem, what are we looking for? We're looking for the rate at which this is going down. So in this problem, what is that?
Has to do with the rate at which A is increasing and changing the two angles that aren't 90 degrees.
No, it doesn't have anything to do with the angles, because now there are some problems that deal with angles, the changing angles, but all I'm looking, because this is B right here, okay, so I'm calling this B. You could have called it anything we wanted, but I'm looking at the rate at which B is changing. So I'm really looking for dB dt. That's what I'm looking for. Now, as I said, there's a lot of variables in these types of problems, and the only thing you can do is you can only have one variable that you're looking for. Well, I know I'm looking for dB dt. Okay? So what is B? What is B? What is the distance? Because now you have to take a look at this and you say, okay, when A is 10, the ladder is still 26 feet, right? I mean, that ladder does not change. What is B? Okay, so we're going to have to use a little bit about Pythagorean, not Pythagorean. Am I thinking Pythagorean theorem? A squared plus B squared equals C squared?
Would
Yeah.
would you use the Pythagorean theorem and then find the derivative of it, and then
No, not yet. All I'm doing is I'm looking for B right now. So if this side is 10 and this side is 26, what is B at that exact moment? Because they told us that they want to know when the ladder is 10 feet from the bottom. So if this is 10, this is 26, what is B? So I'm just going to go A squared plus B squared is equal to 26 squared, right? And we should be able to figure out what B is, because we know A is 10, so that's 10 squared plus B squared is equal to 26 squared. All right, you guys have the calculators and all that. What does B equal? I don't have my calculator with me today. So what does B equal? 24? Okay. So now we have, this side is going to be 24. Oops, looks like a 29. All right, so now we have all these values. So we are going to use the Pythagorean theorem. So we're going to go A squared plus B squared is equal to 26 squared. And this is where, when we take the derivative, it's kind of nice to have a constant over here because we know this is going to be 0. So if I take the derivative here, I get 2a dA dt plus 2b dB dt is equal to 0. And now all I have to do is plug in my values. I know what a is, I know what dA dt is, I know what b is, I don't know what dB dt is. So this is the only thing I don't know. I know everything else, so this is going to be 2 times 10 times 3 plus 2 times 24 dB dt is equal to 0. And now I can solve. This is going to be 30, that's going to be 60. So if I bring the 60 over to this side, it's going to end up being 48 dB dt is equal to negative 60. Divide through by 48. And I end up with, let's see here, 60 over 48, what does that come down to? 30 over 24, which comes down to 15 over 12, which comes down to 5 over 4. Is that right? If I reduced it correctly. Love the latter problem. Okay. Any questions on that? The first, I mean, these types of problems are a little tricky. You got to set the problem up. You've got to, take the derivative and then plug your values back in to solve to find your answer.
So could you do the same thing with like a cone, like finding the volume of a cone? Because I think I remember doing this where you have a cone filled with water and it's dripping out the bottom,
Yeah.
and the rate of change in the
The height. Now that is a much harder problem. Let me see. I think I might have one on here. Okay, right here. All right. This type of problem is much harder. And the reason it's much harder, okay, is because you have to find, what you want to do in these types of problems is you want to find a ratio between the height and the radius or something like that. And I'll show you what I mean when I get here. Because if you think about what is the volume of a cone, do you know what the formula is for the volume of a cone? Okay, what is the volume of a cone? And that is going to be pi r squared h over 3. Now, the problem with this is how many variables do we have in this problem? Without v, how many, because v is just volume, but we have an r and an h. So what we really want to do is we want to write the equation so it's only one variable. And I'll show you how to do that in just a bit. Okay, so let's read this question. It says water runs into a conical tank at a rate of 9 feet cubed per minute. Okay, so what did they just give me? What piece of information did they give me? Okay. Water runs into a tank at a rate of 9 feet cubed. And the units kind of give it away, right? dV dt. They just gave me dV dt. Very good. So dV dt equals 9 feet cubed. Okay, I'm just going to put 9 in there because I don't usually deal with units. It kind of messes with my head. Okay, then it says the tank stands point down and has a height of 10 feet and a base radius. So the height is 10 and the radius of 5 feet. Okay, how fast is the water level rising when the water is 6 feet deep? Okay, so what did they just give me this last sentence? How fast is the water level rising? Okay, so what are we looking for? How fast is the water level rising? That's what we're looking for. So what is that as a variable? What is that? How fast is it rising? That can't be h because h is 10. H is a constant, does not change. But how fast is it rising? dH dt. That is exactly right. That's what I'm looking for. I'm looking for dH dt. That is the question mark here. That's what I'm looking for. Okay. But now I'm really kind of stuck. And it says when h is 6 feet deep. Okay. So h is equal to 6. That's when we want to know how fast it's rising. At that particular moment when h is 6. Okay. So now what I really want to know is I want to be able to rewrite this equation with one variable. So this is what I do. I know that the radius is 5. I know the height is 10. this is a proportion. It always stays the same. It doesn't matter if I go down here and here, the ratio is still the same, okay? So what I do is I say, okay, 2 times radius is equal to height. Do you agree with that? That 2 times radius is equal to height. Is that true? Okay. So now I really want to write my equation as h because I'm looking for dh dt. So I really want my equation to have h in it. So I'm just going to rewrite this as r is equal to h over 2. Is that okay? I'm just rewriting this equation to go to here. And then, do you agree with this? R squared is equal to h squared over 4. Is that a true statement? Because what I really want to do is I really want to rewrite this equation, and I want to replace the r squared. Well, in place of r squared, I'm going to put h squared over 4. So now my volume equation is, watch this, this is kind of tricky, pi times h to the third over 12. Is that a true statement? Okay, because I just put h squared over 4 back in where h squared or where r squared was. So now I have volume is equal to pi h to the third over 12. Now the whole problem is basically, can I take a derivative of this thing? Well, the derivative of this should be pretty easy, isn't it? dv dt is equal to, bring the 3 down, so this is going to be 3 pi h squared dh dt over 12. That is my derivative. Now, I would reduce. I would make this a 4. So dv dt is equal to, what do we have now? Pi h squared dh dt over 4. What am I looking for? I'm looking for dh dt. What do I have? Well, I have h. I also have dv dt. dv dt is 9, is equal to pi times 6 squared. Why 6? Because they told me how fast is the water level rising when h is 6 feet. So I'm going to put 6 in here, but that's 6 squared, dh dt, all over 4. If I multiply by 4 here, I end up with 36 is equal to pi times 36 dh dt. If I divide by 36, and pi, so my answer is just 1 over pi, isn't it? Is equal to dh dt. Now, again, I don't have my calculator. Is 1 over 3.14, is that 0.318? I don't know. I don't have my calculator. But my answer should be 1 over. I would have just left it as 1 over pi as my answer. I don't usually, take it down to decimal points. But Henry, does that answer your question for now? You could have had a problem where it was dripping out and they would have told you how fast it's decreasing. So then the radius is going down and the height is going down, but basically the same concept. The thing you really have to do is you have to try to make sure that you can rewrite the equation with one variable, because you don't want to take a derivative. Could you take a derivative with 2 variables? You could, but then it really makes the problem a lot harder. I think if you can rewrite the problems with 1 variable, much easier to do. No, that's the same ladder problem that we did before. Okay, this one is fairly easy. I'm going to let you guys work on this one by yourselves, okay? Because my dog is scratching at the door right now, so I'm going to go let him in. And you guys work this one out, see what you get for an answer, okay? And then we'll work through it. if you get an answer, just put it in the chat box. We'll see what you get. All right. Caleb says 4 pi. I'm not 100% sure. I haven't done the problem yet, but let's do it. It says the radius of a circle is increasing. Okay, so I've got a circle. The radius is increasing at a rate of 0.2. So they just gave me dr dt. dr dt is equal to 0.2. What is the rate of increase in the area of the circle? Okay, so I'm looking for dA dt. That's my question mark, because it says area of the circle at the instant when the circumference of the circle, oh my goodness, circumference is equal to 20 pi. Huh. Well, I know I'm looking for dA dt, so I know I have to deal with area. So area is equal to 2 pi r. Okay, I can take the derivative of this thing. dA dt is equal to 2 pi dr dt. Okay, I'm looking for this. I have this. Wait. Oh, when the radius, man. Oh, it's 2 pi r squared, isn't it? Nah, I was going to say I don't even need any other information, but I do. So when I take the derivative of this, sorry about that, guys. This is going to give me, so dA dt. No, wait, it's just pi r squared, isn't it? What? I don't even know the area. The formula for the area of a circle, pi r squared. All right, so when I take the derivative, I get 2 pi r dr dt. Okay, so what two pieces of information do I need? I need the radius, and I need dr dt. Well, I have dr dt. They gave that to me. I don't have r, but they gave me this piece of information so I can figure out r. They gave me this piece of information because they said at the instant, they want to know the rate of change of the area. At the instant, circumference is 20 pi. Well, circumference is 2 pi r, isn't it? I hope I have that one right. It's equal to 20 pi. So now if I divide through by 2 pi, I end up with r is equal to 10. So now if I put 10 in here, so now dA dt is equal to 2 times pi times 10 times 0.2. And 10 times 0.2 is 2. 2 times 2 is 4. So that's 4 pi. So you guys had this answer a long time ago. The answer should be 4 pi. Very nice. All right. It says a railroad track and a road cross at right angles. An observer stands on the road 70 meters south of the crossing and watches an eastbound train traveling at 60 meters per second. At how many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection? Now, this is a pretty decent problem. There's a lot going on here. Okay, a railroad track crosses at right angles. Okay, so I've got a railroad track. So so the train is going this way. An observer stands on the road 70 meters south. Okay, so this is 70 meters south. Person is standing here. Let's call this side A. And then it says the crossing and watches an eastbound train traveling at 60 meters per second. Let's call this B. So what did they just give me? Eastbound train traveling at 60 miles per hour. So what did they just give me? They didn't give me B, because this is how fast it's moving. Anytime you're talking about something moving, that's usually a rate, and a rate is a derivative. So they really gave me dB dt. That was 60, okay? It says, how many meters per second is a train moving away from the observer 4 seconds after it passes the intersection? What is B? There you go, 240, yes. A lot of people are gonna say 60, but it was 4 seconds after it passed the intersection. Well, 4 seconds times 60 is 240, so yes, they did give me B also. And now I am looking for, what am I looking for in this diagram? Rate of C. Well, what is that? Is that just C? There you go, dC dt. So I'm looking for dC dt. Okay, so now I've got A, I've got B. Can I figure out what C is? And I should be able to, because Pythagorean theorem says A squared plus B squared equals C squared. So my C value should be, again, I don't have a calculator, so I know it has to be more than 240. So it's probably like 250 or something, because the hypotenuse is always the longest leg. It is 250? Awesome. Okay, and now if I set up my equation, A squared plus B squared equals C squared, well, A is 70. We know that, so we can put that in there. So now when I take the derivative of that, it's just 0. It's gone. So this is going to be 2B dt is equal to 2C dC dt. Well, we know what C is. We are looking for dC dt. We know what dB dt is, so this is going to be 2 times 240 times 60 is equal to 2 times 250 dC dt. See how these problems, you'll have a lot of variables, but there's only one variable you have to solve for, okay? So moving away from him at 57.6, awesome. 57.6 meters per second, excellent. So those are related rate questions. I love them. For some kids, they really struggle with these, but for me, I think they're really awesome. All right. Now, the other things that we're going to work with today is you have to understand when you have a function, if they give you a position function, you take the derivative of position, you get velocity. When you take the derivative of velocity, you get acceleration. Pretty important concepts in calculus. Can anybody just explain the difference between distance and displacement? There's a huge difference between distance and displacement. And we're going to be working with those two words tonight, or this week.
So distance is the like if you walked somewhere, say you took yeah. Sorry, I just read Caleb's message. It'd be the same for me. Say you walk somewhere and you had to turn a corner. So if you walked like 50 meters straight forward and then took a right turn and took 50 meters that way, your total distance travel is 100.
Okay.
But you're actually only displacing yourself. It's where you finally end up. It's the distance between your starting point and your end point if you drew a straight line between the two. So it would be...
Yeah, you'd have to use Pythagorean theorem on that one, 50 squared plus 50 squared. Yes, I agree with you. Usually when we do in calculus, we usually talk about a straight line, okay? So let's say I started here. And I walked, let's say 10 meters. Let's say that this is 10 here. So I walked here, cross that out, and then I came back 4 meters. Okay. What is my distance that I traveled? What is my displacement in this problem? Okay, my distance is?
Distance is 14 and displacement is 6.
Correct. So there is a difference between distance and displacement. Okay, and usually in calculus we talk about straight line motion. Okay, something goes out, comes back, goes back. So that's what we're talking about. When they ask for distance and displacement, there's a huge difference there. Okay, so motion along a line. Suppose an object is moving along a coordinate line so that we know its position, s, on the line as a function of time, t. The displacement of an object over the time interval is just how far it's gone. Okay, it could go to the left, it could come back to the right, it could turn around. Average velocity, average velocity is one that most kids get wrong. Average velocity is displacement over time. Okay, displacement, average velocity is displacement over time. All right, so let's try a problem. An instantaneous velocity is just the first derivative. Speed is the absolute value of velocity, so speed is always positive. So let's try, no, I don't want to try this problem, I want to try acceleration is the derivative of velocity. Free fall, yeah, I want to get to a problem. Here we go. A particle moves along a line so that its position at any time t is greater than 0, because t can't be negative, is given by the function t squared minus 3t plus 2, where s is measured in feet and t is measured in seconds. Okay, so here is the type of question that you will always get. Find the displacement during the first 5 seconds. Find the average velocity during the first 5 seconds. Find the instantaneous velocity at t is equal to 4. Find the acceleration. At what values of t does the particle change directions? Where is the particle when s is at a minimum? All right, so now this problem here is much easier to do in second semester. Well, I suppose it would be first semester in BC Calc, because when you're dealing with integrals, much easier to find where the particle ends up. But what I'd like you guys to do is I'd like you to answer all those questions. And I want to see if we get the same answers, okay? And then I will work it through and see what we get, all right? So you guys take a little bit of time, work on that problem, see what you get. If you guys want to just write your answers next to each problem, that would be amazing. Or you can put them in the chat box. That way I'll know when to go.
Do you want us to solve one, then write the answer, or solve all of them and then write all the answers?
It makes no difference to me. If you have 1 or 2 done, you can just put those answers in there and then continue on the other ones, or you can just put them all in at the same time. It does not make good. Working, I'm just going to ask a couple questions. Are you two going to take the BC Calc test at the end of the year?
Yeah, that's my plan.
Okay. Did you guys get my email yesterday about AP testing? Okay. I just want to make sure that it went out. All right. So remember, by November 8th, if you are going to test, you definitely want to pay for it. And you do it in the same place. You do it in that College Board site. And then once you figure out if you're testing, please email me where you're going to test. Because, you know, some of you will test in Waukesha School District. Some people will test in the Appleton School District. Some people will test in the Green Bay School District. Caleb, where did you test last year? Hortonville? So I'm assuming you're probably, now, I'm not 100% sure Hortonville has the BC Calc test, so you have to make sure, because some schools, they have AB Calc, but they don't have BC Calc, so you can't take, if they don't have it, they won't give it to you. So you might want to make sure you check to see if Hortonville does have, or if they are going to do the BC Calc test, okay? Because if not, then you're going to have to find a school district that does offer the BC Calc exam. Okay, as long as they have some kids taking the BC course, they will have the BC test. So yeah, you guys will be able to take it right there. Awesome. All right, I'm going to start walking through this problem. I'm a visual learner. I know Caleb probably heard me say this 100 times last year. If I was going to do this problem, the first thing I do is I try to figure out where that particle starts. So S of 0, where it starts, well, it starts at 2 on the number line, doesn't it? So here's my number line. At time t is equal to 0, the particle's at 2. And then it's going to travel, and at s equals 5, that particle's at, let's see here, 25 minus 15 plus 2. So that particle's at 10. Let's see here. So that particle's at 12. So t equals 5. It's at 12. So the displacement is 10. Is that right? Because I don't see any answers that are 10 up there. Okay. So my displacement for the first 5 seconds is 10. What is it? Meters? It doesn't really say, does it? So I'm just going to go meters. Find the average velocity during the first 5 seconds. Well, velocity is displacement over time. So that is going to be 2 meters per second. Okay. Oh, Henry's got, all right. Henry's got all of them on there. Okay, at one time. All right. And then it says find the instantaneous velocity. Well, instantaneous velocity is the first derivative. Okay, this is position, so instantaneous velocity, so that would be 2t minus 3. If I plug in 4 now, that's 8 minus 3, which is 5 feet per second. It would be 5 feet or 5 meters per second squared, wouldn't it? Since it's velocity, I think, if my units are correct. Find the acceleration of the particle when t is equal to 4. Well, if I take this is velocity, so acceleration would be the next derivative, so that's just 2. That's an easy one. At what value of t does the particle change direction? Well, particle changes direction when velocity is equal to 0, doesn't it? So if velocity, my velocity function is 2t minus 3, I would set that equal to 0. So 2t equals 3, so t is equal to 3/2. Is it going to change ever again? Is the particle ever going to change directions again? Okay. And the answer to that question is no. It's going to, at what value does the particle change direction? It changes directions at 3/2. It's never going to change again because the velocity is never equal to 0 again. So it's only going to change one time. Okay, and where's the particle when s is at its minimum? Okay, so at t is equal to 0, it's 2. So I'm going to plug 3/2 in here. Now, I don't have a calculator, guys. So what is, if I put 1.5 into t squared minus 3t plus 2, what do I get? Because I don't know. I would assume it's going to be down here someplace. I would assume the particle started off going to the left. That would be my assumption. Okay, so what is 3 halves squared minus 3 times 3 halves plus 2? What does that equal? That's one thing I don't know, and in order to solve this problem, I need to know that. And by looking at Henry's answers, I would say that it's 1.5. Is that correct? Negative 2.5. So when I plug this in, the farthest to the left it ever goes, so at t is equal to 3 halves, or 1.5 seconds, this particle, oops, is at negative 0.25? Okay. So here's another question that will be asked. You put the time value in, not the, put the time value in. So did you put 3 halves into the position function? So what I really want to know is, what is S of 3 halves?
Yeah, so when I my answer is the time value. So
Oh, okay.
the time value when S is at a minimum, not the S value.
Gotcha.
The position.
Okay. So now the last question, if this was really a question I was going to ask, the last question I would ask is, how far did the particle travel? In 5 seconds. Okay, so how far did that particle travel in 5 seconds? Not an easy question, but if you take a look at my diagram, it shouldn't be too bad. How far did that particle travel in 5 seconds? What is the distance it traveled? Caleb, you are saying 3? That's the total distance? 13? I'm not liking that either. Okay? Because if you look at this, I start at 2 and I go all this direction until I get to negative 0.25. How far did I just travel to the left? Isn't that 2.25? Okay. And then I go from negative 0.25 all the way to 12. Well, that is 12.25 units. So if I add those two together, I should end up with 14.5. That is the total distance that particle traveled in 5 seconds, because it traveled to the left 2.25 units, and then it traveled 12.25 units to the right. Now, if we were in second semester AB calculus, all we would do is we would do 0 to 5 of t squared minus 3t plus 2, right? The integral, the area underneath that curve, is going to give me the total distance traveled. So if you put this into your calculator, you should get 14.5. That is an awesome problem. Being able to find displacement, distance, average velocity, instantaneous velocity, acceleration. Those are all the things that you need to be able to do this week, along with related rates. Whew, that is all I have for you guys for today. That was some cool stuff, some really awesome stuff in there. Any questions on any of that stuff? When you start using integrals, or when we start doing, I really enjoy this stuff, the related rates, the displacement, average velocity. I mean, because it starts using why we use this math stuff. I mean, that is, to me, that is the cool stuff with math, because you don't know how many years I've been teaching and how many times I've heard kids say, when are we ever going to use this stuff? Well, you really don't use upper level, until you get to upper level math questions, you really don't use the math that we learn. And look at all the stuff that you had to use in this problem. You had to use evaluation. You had to be able to evaluate this. You had to be able to factor. There's so many different things that you have to be able to do in order to do these types of problems, which is, I think, what makes math fun. All right, you guys have a great week. And next week is a short one. Only 3 days next week. Only Monday, Tuesday, and Wednesday. All right, you guys have a good one. Caleb, good luck this weekend with your soccer tournament. Bye. Henry.